Hey everybody, this is Larry. This is June 28th of the June Leetcode Daily Challenge. Only a couple more days to go, so give yourself a pat in the back, hit the like button, and hit the subscribe button. Join me on Discord, let me know what you think about this problem, and if you somehow just stumbled in, I'm going to also do the July challenge as usual. I think I have a 400 something days going. I haven't missed one yet since April of last year. You do the math, I think it's 4 something, but so yeah, so gonna keep that going anyway. Today's problem is gonna be remove all adjacent duplicates in string. I usually solve these live, so if it's a little bit slow and I ramble on a little bit, fast forward or whatever you need to do. Okay, so this problem is you're given S, lowercase English letters, removing two adjacent, we repeatedly move until we no longer can. So we just compress. Oh, okay. So you remove both of them, not just one of them, and you kind of keep doing it. So this one screams stack to me, and I think if you have, because you can think about it, and I don't know if this is the clean way to think about it, but the way that I think about it is that sometimes you have to think about how to process them. If you try to figure it out in linear time, then if you try to figure out in linear time, you can only go left to right or right to left, and then you just try to figure out what can you do when you go left to right or right to left. But you can just reverse it in that if the problem calls for it. In this case, as you add one character at a time, you can remove a duplicate by comparing the last character with the current character of the last character. And because of that, you can kind of keep on redoing that and then removing it. So that, of course, you can actually emulate that with a string, but of course that also has a natural translation to a stack. And that's basically what we're going to do here. Yeah. Basically, every time we add a character, we remove the previous one. And in this one, because, I didn't even take a look at n yet. I guess if n was small enough, you could do something n squared. But in this case, given that n is equal to 10 to the fifth, it is, and our algorithm is O of n, so I don't have to worry about running time for the most part, because it's going to be fast enough. You may ask yourself also while looking at this question, like, is there an n log n solution? And when I see a problem like this, I don't really feel like there's a log n answer, because you're not looking previous or you're looking only on immediate neighbors, right? So there's no like weird lookups in either direction as you kind of go through the array, or sorting for that matter. So for me, that did not need to be. So I don't think there'll be an n log n. I'm just going over my thought process, and that's why when I first saw it, I'm like, oh, this is just a stack. And the final answer is unique. I mean, I guess that's true. So yeah, so let's get started. So let's have a stack, and then now just for character in S, there are a couple of ways to do it. I mean, you can just compare it to the top directly. You can add it and then compare the last two, which is what I'm going to do, I suppose. And stack -1 is equal to stack -2. Then stack that pop, stack that pop. This removes the duplicate, and then at the very end, stack will, I do a little bit, I wouldn't say cheating, but just that stack will contain in order the string that we need. So we go from left to right on the stack, which is a little bit obviously not an inherent thing in a stack, but I guess the more canonical thing to do would be to pop everything off the stack and then reverse it. But this should be good. Let's put in more test cases first before, maybe test some edge cases. I think this one is good at compressing them. Oh, okay. 0 is not a valid test case. Wasn't sure. Also, things may get weird, so all right. Cool. All right, let's give it a submit. Yeah, looks good. Like I said, because it's linear time and linear space, I don't really worry about the complexity. I think that's pretty much it. Um, yeah, I think. I think if you so there are a couple of things. One is that if you really so if you have to use extra space and you're not changing the input, then this is the best you can get. I think you can actually do this in place with a two pointer type thing. Um, with a pointer as an implicit stack onto the input string. Of course, this actually doesn't work in Python, but in certain languages, you can do that, and then you chop it off or something like that. Like certainly in C, maybe C++ type thing, maybe not C++ string, but maybe, because then you could just denote the last thing as 0. But I guess in theory, there could be all of one in-place algorithms if your language supports character strings or character arrays of strings in a funky way. If you don't know what that means, then it doesn't really matter, to be honest. But those of you who are using a language that support that, then you can get it in all one extra space, if you will. Using basically the same idea, but using like the two-finger, two-pointer algorithm, not like pointers. So I mean a little bit of that as well. And then the thing that is left is that oh yeah, and I would normally also say that in-place algorithms are terrible because you change the input, and usually people don't want you to change the input. Why are you changing my input? Leave my input alone. But in this case, with the function name called remove duplicates, I could kind of see an argument for doing in place, because you're trying to act on an object, not just get an answer as a result of an object, right? So I could see that. So I'm a fan of that. But yeah, that's what I have for this one. I think Yeezy Monday, maybe. Hope y'all have a great week. Happy Monday, and let's finish up June, and I will see you later. Stay good, stay cool, and to good mental health. Bye bye.